Workhorse: how upgrades will keep 1950s-era C-130 cargo airplanes flying. Could 1950s Air Force C-130 cargo planes fly missions for nearly 100 years? If not 100, what about 80? At least 80 is probably realistic given the series of recent upgrades to the existing C-130H aircraft, now converted to the newer high-tech C-130J that is slated to arrive at a select number of Air Force locations this year. Air Force and Navy bases in Kentucky, West Virginia, and Texas will begin receiving 8 C-130JS this year. The 4th Air Force location will receive the aircraft at an undetermined time, according to an Air Force report. Compared to the older C-130, the J model ascends faster and higher, flies farther at a higher cruising speed, and takes off and lands in shorter distances, the Air Force report said. The C-130J aircraft incorporates a wide scope of upgrades and adjustments, including a new 2-pilot flight station, digital avionics, multifunction color liquid crystal and head-up display, inertial navigation technology, and GPS. The fuselage itself is also a key focal point of the effort, Air Force developers explain, which includes replacing and strengthening the plane's center wing box where the wings are attached to the fuselage. The aircraft also features a fully integrated defense system, low-power color radar, digital moving map display, new turboprop engine with 6-blade composite propeller, and digital autopilot. C-130J also includes improved fuel, environmental and ice protection, and an improved cargo handling system, the Air Force SA wrote. The upgrade also includes adding a new 8.33 radio for improved communications along with a new cockpit voice and digital data recorder. The C-130 will also receive new collision avoidance technology, a technology that relies on advanced algorithms to identify hazardous terrain or other obstacles and, if required, redirect the aircraft if the pilot is unable. As a propeller-driven aircraft, the C-130 is capable of flying at low altitudes, landing in tougher conditions, and withstanding inclement weather such as fog. The propellers make aircraft engines less susceptible to flying debris and causing operational problems for the engines. In contrast, Air Force C-17s need to operate in more defined conditions, such as areas with longer, separate runways or runways. Flying debris or uneven terrain can pose complications for the C-17 engine. While the C-130 is specifically designed for low-altitude, high-risk combat zones with uneven terrain, scenarios that require endurance and maneuverability. In fact, in so-called hot or active combat zones, the C-130 often drops weapons, supplies, and even troops when called upon by the commander. Increased acceleration like this of course brings a tactical advantage as well. More maneuverable aircraft are better able to handle and accelerate, less vulnerable to enemy ground missile attacks. These tactical and technical dynamics are part of why the C-130 upgrade combines propeller improvements by replacing the hydromechanical propeller control system with an electronic propeller control system, EPCS. EPCS improves safety by speeding up response times when the throttle is advanced quickly, problems in previous crashes. Legacy propeller control systems use 1950s technology and are a significant driver of maintenance costs. EPCS maker Hamilton Sundstrand says the new kit replaces the 54H60 propeller mechanical control with a system based on digital computer software, offering greater reliability and more precise performance.